Namaste children, a warm welcome to all of you for this second session. I am T.K. Prasannamurthy from Bangalore. In the previous session we have discussed chapter number 4, circles. Today we are going to briefly revise another important unit, the next chapter, chapter number 5, areas related to circles. Circular shape, it's a very important shape that we come across very frequently in our daily life. Okay, you have seen the wheels, the tires of automobiles. See here, see the wheels. From a toy I am just showing it to you. So this is in a circular shape. Then the compact disc, the CD, this is also in the circular shape, and then plates and jars, utensils that we use in our kitchen, and then base of a cone, that of a cylinder and frustum, etc. They are all some of the important examples for circular shape. So in this session it is worth to discuss about this circle, the circular shape, certain important basic concepts of this. Okay, children, in this table, a wonderful table, you have got lots of information that you can make out from these tabular columns. So here we are going to mainly discuss two important concepts, that is sector and segment of a circle, their related formulas, and then combination of those two figures. So it has altogether about 41 problems are there, excellent problems are there. Let us try to understand one by one. So the first and the foremost point to be discussed is the circumference of a circle. See, what do you mean by a circumference of a circle? Okay, circumference of a circle is nothing but the length of the boundary, one complete round. What is the length of this boundary? So for that concept we use the term circumference, suttadate. Okay, so in Kannada we are going to call it as suttadate. The length of this closed curve, okay, is called the circumference of a circle. Okay, circumference of a circle, here is a circle with a diameter, and there also on the other side there is one more bigger circle and with the diameter. We shall try to understand, is there any relationship between the diameter and the length of this curve, that is called the circumference. Let us try to explore it. You can see here in this bangle, okay, see, look at the diameter and the circumference. It has some circumference for this diameter. So there is another bangle here, is little bigger. So the diameter, you compare the diameter of these two bangles and respective circumference. You can see here that as the diameter increases, the circumference also increases, and as the diameter decreases, the circumference also decreases. So this is one important relationship that we need to understand. That is what we can understand from these two figures. So circumference of a circle is directly proportional to its diameter. What do you mean by this statement? Proportion, direct proportion. Let us try to understand this. Symbolically we write this as C proportional to D. This is alpha from Greek. Okay, we should be read as proportion. Here both of them are in numerator, therefore you must read it as C directly proportional to D. In other words, as diameter increases, so the circumference decreases, as diameter decreases, the circumference also decreases. So this can be further explained like this, by considering 3 to 4 circles, comparing them with their circumference. Here is a small circle with the diameter. Let us take the ratio between the circumference and diameter, call it as C1 by D1. one more circle, say a little bigger circle, it has so much of diameter, take the ratio between their circumference and diameter, keep it aside. One more example, a bigger circle this time, again take the ratio between their circumference and the diameter. Like this you can go on finding the ratio for their circumference and diameter for any number of circles. Say here let us call this as the ratio as Cn means the circumference of this circle divided by Dn means the diameter of this lost circle. And if you now observe this, compare all these quotients, you will see that C1 by D1 is equal to C2 by D2 and C2 by D2 is equal to C3 by D3 and C3 by D3 is always equal to Cn by Dn and Cn by Dn is equal to K, some constant K. So, in all these cases, however big the circle may be or smaller may be, the ratio between the circumference of the circle to its diameter is always a constant. So, if the quotient is a constant, we say this proportion as direct proportion. Okay. So, therefore, we can rewrite this as circumference of any circle divided by its diameter is always a constant, some constant. Let us denote this constant by the letter K. Instead of the letter K, we use or you can before that you can cross multiply this. So, C divided by 1 is C, K into D is K into D only, and here this K is called as the proportionality constant. It is called the constant of proportion. Now, instead of this K, now we are using a Greek alphabet, that is pi only. So, therefore, C is proportional to D, or we can say this as in the form of an equation. If you want to represent, you can call this as C is equal to pi into D. What does it mean? It means that if you want the circumference of a circle, you measure the diameter and multiply a particular value called the constant of proportion. In this case it is equal to pi, multiply those two, you will get the circumference of the circle. So, C is equal to pi times D. So, circumference of a circle is directly proportional to its diameter. Symbolically we write like this. If you want to write it in the form of an equation, we write it as C is equal to pi times D. Okay, where pi is instead of K, we are using pi here, it is called proportionality constant. So, if you write it in the form of words, it will, you can read it like this: circumference is equal to a constant pi times the diameter. So, if you multiply these two, diameter by a constant pi, that will be equal to the circumference of the circle. Or you can put it like this: circumference of a circle divided by diameter is nothing but that is the constant pi. Okay. Now, instead of diameter, can we not write, since it is equal to twice the radius, we can write this C as pi times 2r. Okay. So, now we can use the commutative property of multiplication and we can say it is equal to 2 pi r. So, if you multiply 2 pi and r, the product of that will be equal to the circumference of the circle. Hence, this formula, this is the formula to find the circumference of a circle. Now, let us take a particular example and find out what happens to the circumference if the radius is half a unit. So, we just now understood that circumference is 2 pi r. Okay, in place of r, you write substitute 2. So, 2 got cancelled and we get circumference is equal to pi. So, if the radius of a circle is half a unit, then the circumference and that proportionality constant, they will be both equal to each other. Now, let us consider one particular example for the circumference of a circle by taking wheels which are rotating, we are moving like this, and try to apply the formula C is equal to 2 pi r. Okay. Now, so this is one image you are seeing, here also you are able to see this. Okay. What is the distance moved by a wheel in one rotation? Say it is moving like this. When it moves for one complete rotation, what is the distance it covers? That is what we are interested to find out now. So, you know the distance travelled by a wheel when it makes one rotation, don't you think that is equal to the circumference of the circle? So, therefore, the distance moved by a wheel in one rotation, it must be equal to the circumference of that wheel. Okay. Now, let us reverse this process. If the distance travelled by a wheel is equal to its circumference, then can we say that the number of rotations that made by it must be equal to 1 only. If the distance travelled by a wheel is exactly equal to its circumference, then we may say that, we can say that the number of rotation it has made is just 1 rotation. Now, it has travelled for 1 minute, say. If the distance travelled in 1 minute is x, in such a case, how many rotations it would have made? So, that is we are interested. Okay. So, if the distance travelled by